The famed Mandalay Hill. Located near the Mandalay Hill are the ruins of the royal palace. 100 years ago, the last of the ancient dynasties fell. The stately palace buildings were razed to the ground by the Second World War. The ramparts and the moat are all that are left of those ancient glories. On January 4th, 1948, Burma achieved independence, freeing herself from the colonial rule which had lasted for a century. Independence Day. Burma marches forward as a rising nation. Rangoon. An enormous task now awaits this young nation, the task of carrying out the urgently needed economic development in order to elevate the country's position as an independent nation and to promote the welfare of the people. In 1954, the government of Burma formulated an industrialization program to cater to the immediate needs of the nation. As a result, a number of factories, including a steel mill, cotton mill, jute mill, and a pharmaceutical plant were established around the capital. The steel mill, producing rods, wires, and nails. This is the cotton mill. At the same time, a plan to develop electric resources was also mapped out to supply the necessary power for industrialization. Under the Power Development Program, 3 projects were envisaged by the government. They are the Sangtin Falls Project, the Pigu Project, and the BALUCHAUNG Project. This BALUCHAUNG project had conditions most favorable of the 3. The project site is located near Loi Khao on the lower reaches of the BALUCHAUNG, which flows out of the Inle Lake. It was with this background that the Electricity Supply Board of the Ministry of Industry launched the BALUCHAUNG project in 1954. The next year, the government decided to finance about 60% of the project with the payment of the war reparations from Japan. The Shan Plateau, 3,000 feet above sea level, spreads far and wide in the east of the central plains of Burma. The Inle Lake, situated on the eastern part of the Shan Plateau and near the town of Tongji, the capital of Shan State. The Inle Lake is famous for its scenic beauty. Here, the boatman rows with his foot. A novel way of fishing. The fisherman beats the surface of the water to frighten the fish out of the underwater weeds. The district around the Inle Lake is famed for the production of elegant silk fabrics. There are looms in most of the lakeside houses, and the people weave silk yarn into unique patterns. People here have enjoyed a quiet and peaceful life for centuries. The floating bazaar. Lake is brimming with water all the year round and provides a rich and constant supply of water to the BALUCHAUNG, which flows out of the lake and then meanders down southwards across the Shan Plateau. The BALUCHAUNG flows for about 70 miles on the flat land. The river enters the town of Loiko, the capital of Koei State, situated at the southern extremity of the Shan Plateau. Past the town of Loiko, the BALUCHAUNG flows through the jungle, where it is visited occasionally by villagers to draw water. By and by, the river changes its phase from a gentle flow to a series of falls and cascades deep in the jungles. Soon the BALUCHAUNG plunges over the brim of the tableland 1,400 feet down into a deep gorge. Called the Lopita Falls, the cataracts are surrounded with steep and dangerous terrain, making it extremely difficult to approach them. Even jungle men dare not go near them. Early in 1954, a survey team, including Japanese engineers, proceeded to the proposed site of the BALUCHAUNG project. From Loiko, the party pushed its way as far as it could by motor car along narrow bullock cart tracks. At a point about 6 miles from Loiko, the survey team set up a camp beside the BALUCHAUNG. Based on this camp, the team proceeded with the survey of the topography, the ground levels, the quantities of flows, and so on. Guided by local inhabitants and under the escort of Army personnel, the survey team climbed the Rocky Mountains to see the fabulous Lopita Falls for the first time. The cataracts, secluded from human access from time immemorial, presented an awe-inspiring view. The struggle with the jungle began immediately. Survey teams descended to the bottom of the gorge, negotiating the thick jungles infested with venomous snakes and tigers. The Burmese and Japanese engineers steadily forced their way through the jungle. At the base camp by the riverside, the results of the preliminary surveys were studied closely, joined by the brains of the Electricity Supply Board. The purpose of the preliminary survey was to confirm the potential hydroenergy of the BALUCHAUNG and to study how the prospective power station should be designed. This survey had revealed that the drop between Loiko and Lopita is 260 feet, the Lopita Falls 1,450 feet, and between the basin of the cataracts and the point where the BALUCHAUNG meets the river Nampoon downstream, 400 feet. Hereupon, the construction of 3 power stations was planned, centering around the Lopita Falls. The first one on the upper reaches to produce 24,000 kilowatts. The second one near the Lopita Falls to produce 168,000 kilowatts. And the third one farther downstream to produce 48,000 kilowatts. The capacity of the 3 stations totaled 240,000 kilowatts. Beginning in April 1954, detailed topographic survey and geological investigation of the prospective site of the No. 2 power station were carried out for 6 months in the wake of the preliminary survey. The first priority was given to the construction of the No. 2 power station. The periodical discharge gauging and daily reading of the river water level were continued to ascertain the quantity of flow of BALUCHAUNG. The survey team rested and ate lunch near the basin of the cataracts, a place no human has ever dared approach before. The survey operation continued. Tokyo. The designing of the BALUCHAUNG No. 2 power station was made in Tokyo by the Nippon Koei consulting engineers based on the detailed survey and investigations. At the company's head office, various plans for the project were studied with the chief engineer of the Electricity Supply Board presiding. The advantage of this power station is that the high waterhead is available due to the enormous natural drop of the Lopita Falls. This is an outline of the plans for the No. 2 power station. The stream of the BALUCHAUNG is diverted at a point above the Lopita Falls and led into a pondage and down to the power station to be built at the bottom of the gorge. An intake is built some 3 miles above the falls to draw the flow into a waterway called a head race. The 10,800-foot-long head race leads the water into the pondage, which is capable of storing 3 million cubic feet of water. Thereon, the water flows into a concrete conduit. At its end, the concrete conduit divides into 2 steel pipelines called low-pressure pipelines. The water runs through these pipelines to the surge tank. After entering into penstock lines, it rushes down to the power station below. 6 sets of 40,000 horsepower Pelton wheels rotate 6 alternators, each with a capacity of 31,000 kilovolt amperes, to generate a total of 168,000 kilowatts of electricity. 1/2 of this is to be installed in the first stage to produce a total of 84,000 kilowatts. The access road from Loikaw to Lopita has been completed, and the construction goes into full swing. Today's work begins at the motor pool. Various pieces of construction equipment are heading toward respective job sites. Excavation of the head race. 4 scrapers are at work for this operation. First, a bulldozer pulls a rooter and softens the earth. Then the scraper shaves off as much as 4 truckloads of earth at a time. The Kajima Construction Company of Tokyo provided key engineers and technicians. Each scraper scoops and carries 12 cubic yards of earth at a time, as efficient as 300 men's work. Backhoes and dragline shovels are used for underwater excavation and deep channel cutting. This is a dragline shovel. Excavation for the concrete conduit. In rocky places, power shovels, dump trucks, and bulldozers operate in teams. The access road zigzags down the side of the gorge. At the bottom, the site of the power station is seen in white relief against the thick green of the jungle. And above it, the excavation work for the penstock line is going on over the steep slope. The jungle is cleared, and a bulldozer scrapes off the surface soil. The excavation of some 125,000 cubic yards of earth for laying the foundations of the penstock line is carried out under the most difficult conditions. Operating bulldozers over the steep slope of nearly 40 degrees elevation is extremely risky. Under expert supervision, the operators handle this tricky job. Then the ground is dug to the rock bed to sink concrete blocks for anchoring the penstock line. Meanwhile, in the hot and stuffy air at the bottom of the gorge, the construction of the power station building, 375 feet long and 90 feet wide, is making headway. Concrete is poured over the foundation. A concrete pump sends concrete into the places efficiently through lines of steel pipes. Substructure of the power station building is taking shape day by day. Now, where is the electricity generated at this power station transmitted to? According to the power transmission plans, 2/3 of the power is to be supplied to the consuming areas in the south, including Rangoon and Taungoo. The remaining 1/3 to Mandalay, Meiktila, and Shan states. The transmission line to Rangoon is over a distance of 250 miles, and to Mandalay over a distance of 240 miles. The Rangoon transmission line crosses the mountainous region between the power station and Taungoo, covering a distance of 130 miles and a height ranging from 4,000 to 5,000 feet above sea level. This made it necessary to build a new road from Loiko to Taungoo, closely following the route of the transmission line. The mountainous terrain through which the Taungoo Road will be constructed. The staff of the Electricity Supply Board and the Japanese engineers began tackling this difficult task with the liberal cooperation of the local inhabitants. First of all, the jungles are cleared, the thick tropical jungles previously untouched by the woodman's axe. A plant with thorns all over it. Engines roar in the jungle area where, until recently, not even bullock carts could pass. The people in the mountains, secluded from the outside world, rejoiced with the new prospects and willingly cooperated in the road construction. The new road runs past this sleepy hamlet, which must have lain eventlessly from remote antiquity. A new age is now knocking at its door. The Taungu Road, now fully completed and ready for trucks and trailers roaring past, loaded with construction materials for the transmission line. Besides its role in constructing the transmission line, the completion of the Taungu Road is of no less importance, as it opens one of few communications traversing from east to west. Back at Lopita, most of the excavation work was completed in 1958, and people are now busy laying concrete. Since sand and gravel, the main components of concrete, are not available locally, these had to be made artificially from limestone taken from quarries. This rock crushing plant is capable of smashing and sifting out 90 tons of rock per hour. This rod mill crushes gravel into sand. Sand and gravel are stored in graded piles. These materials and cement are automatically weighed and sent to mixers in the batcher plant, the heart of the concrete operation. The agitator trucks loaded with concrete hurry to the job site. The laying of concrete at the head race. First, the bottom slabs are laid. Reinforcement bars are assembled, shuttering set up, and concrete is poured. The laying of concrete in the pond. The earth is rolled, over which concrete slabs, each 60 feet square and 1 foot thick, are laid block by block. Concrete is compacted by vibrators. The enplaced concrete is moistened with water for several days to prevent cracking. The construction of the low-pressure concrete conduit is progressing smoothly. It's a kind of large concrete tunnel, 14 feet in diameter and 2,600 feet long. First, the inside panels are set up. Next, reinforcement bars are assembled. Then the outside panel. Concrete is poured. The inside walls of the conduit are coated with cement mortar by means of a spray gun. The concrete for the penstock line is unloaded from agitator trucks into the bucket of the rope haulage. This 3,000-foot-long rope haulage is provided especially for the penstock installation. Concrete is poured into the foundation of the penstock line over the chute. By the end of 1958, the building of the power plant was almost completed. A total of 450 tons of steel frames were used for the building. This is a model of the turbine generator. This is a Pelton wheel turbine, which is used in the high-head power station. A water jet through the nozzles drives the wheels on both sides of the generator. At the factory in Japan, the turbines and generators to be installed at the BALUCHAUNG power station are being manufactured. This is the runner of a turbine. turbine has been fully assembled. The chief of the Burma Reparation Mission and the chief engineer of ESB visit the factory to inspect the machine. The port of Rangoon. Generators, turbines, and various equipment transported from Japan are being unloaded. The stator of a generator. Loaded on railway cars, the equipment was transported for about 380 miles. The train runs north to Thazi via Tonggu and goes up the Shan Plateau, arriving at Ong Ban. The transit store yard was built specially for this project. Tens of thousands of tons of equipment and material are unloaded and dispatched from here. A convoy of trailers loaded with penstocks now leaves the Ong Ban yard, heading for Lopita, some 100 miles away. The convoy speeds across the Shan Plateau. The entire course of this Ong Ban road had to be improved for the transportation of this heavy equipment. The convoy reaches Lopita. Early in 1959, the intake is almost complete. What remains to be done now is to fix the gates. The head race has also taken shape. The concrete water channel stretches far into the jungle. The entrance to the pondage is completed, and so also the pondage. And the concrete conduit. At about this time, the low-pressure pipeline is being installed. This pipe is about 9 feet in diameter. The pipeline extends for about 3,600 feet to the surge tank. The surge tank, made entirely of steel, rises to a height of 200 feet. This is provided to absorb a rise of water pressure caused by a sudden pull of water flow in the penstock due to a big change in generator load. Over the steep slope below the surge tank, the installation of penstocks, about 3,200 feet long, is progressing. The rope haulage is busy at work lowering the penstock shells. It's quite a tricky job maneuvering the huge steel pipes, each one weighing over 10 tons down the nearly 40-degree slope. But the workers manipulate the rope so adroitly that the penstocks come down into position without hitch. As soon as they are secured in position, the penstock shells are welded. The tropical sun makes the welding operation a really trying job, and often it has to be carried out at night. This is the spherical branch. In March 1959, when about 1/3 of the penstock line had been installed, the power plant building was completed. The trailers hauling the various parts of the generators from Ong Barn are now on the access road with its hairpin curve, the last but tricky course to the power station. Within the building, the erection of the turbine generators is underway. The setting of the runner. Meanwhile, the construction of the transmission line is in progress. The steel towers are being erected. In this way, a total of 1,200 steel towers have been erected over a distance of 250 miles from Lopita to Rangoon. Now the stringing of cables. This is a tension line, 230 kilovolts, which transmits power at high efficiency. Thanks to the strenuous efforts of these people toiling under the scorching sun, the transmission line extends further and further over the mountains and across the fields. By the end of 1959, every section of the BALUCHAUNG No. 2 power station was completed. The intake. All of the 6 weir gates are now complete. By closing these gates, the flow of the BALUCHAUNG is stemmed and channeled into the head brace. The day has come for the water of the BALUCHAUNG to be taken in. Lined up are the hoists of the gates. The switches are thrown, the motors turn the winches, and the gates are lowered down. Now fully closed, the countenances of satisfaction. One gate is open to let surplus water overflow. The water from the intake runs in the head race. The head race crosses beneath a stream in siphon conduit. The pondage, brimming with water. It's about 1,200 feet long, 360 feet wide, and 10 feet deep, and stores 3 million cubic feet of water to meet daily peak load. The water from the pondage passes through the concrete conduit into the low-pressure pipeline. The surge tank. The penstock line. The power station. Now all complete. Inside, the 3 turbine generators are undergoing final adjustments. All spick and span, they await trial operations. These generators are remote controlled from the control room. Young engineers learn how to operate the controls.
バルブの位置に持っていくを引けばバルブの下位のドームに入る。
ဒီマスターコントロールမှာကိုလှည့်ပြီးတော့ဟိုမှာဆိုတော့ဘာ start excite synchro အဲ့လိုလှည့်လိုက်လို့ရှိရင်ကျွန်တော်တာပိုင်းကအစစ်အစစ်နဲ့စစ်စစ်ကိုသူ့ဟာသူလဲသွားတယ်ဖြစ်တယ်။ဒါမှမဟုတ် master control ကို stop ဆိုတဲ့ position ကနေပြီးတော့ bar ဆိုတဲ့ position ကိုဆွဲပြီးတော့ပေါ်တင်လိုက်တယ်ဆိုလို့ရှိရင် generator အနေနဲ့စတယ်
これでバルブが開いてランプインジケーターにバルブ回の表示が出る。
バルブ見るဆိုတာねバルインジケーターのハースがပေါ်လာတယ်。
これからタービンスタート。
The outdoor transformer yard. Here the voltage of the generated power is stepped up and sent to the transmission line through switch gears. The transmission line is also fully prepared for operation. The line runs along the Tonggu Road over the mountains, rising to 4,000 to 5,000 feet. The Rangoon substation, located in a suburb of Rangoon, is now completed. This substation receives the power and delivers it to the city of Rangoon and its environs by the secondary transmission system. The huge transformer to step down the voltage from 230 kilovolts to 33 kilovolts. In December 1959, after 5 years of hard work and unremitting efforts of all concerned, the test operations of the power station, the transmission line, and the Rangoon substation were made possible. The engineers take up their positions. The trial running begins. Intensive meter reading. The tail race. The BALUCHAUNG has now been harnessed for the first time in history. A series of careful tests continues. Sundays are given up to expedite the tests. A test of the speed governor one of the most delicate mechanisms to control the turbine generator. The output of the generator is raised to its maximum and is abruptly switched off to examine the performance of the governor to ensure the safe operation even in cases of emergency. The load of the generator is now raised to a maximum. Measured values are collected immediately, and the results of the test are carefully checked. Early in March 1960, the day came for the trial operation of the entire transmission system from BALUCHAUNG to Rangoon. Tense moment arrives. Engineers watch the meters attentively. The voltage is raised, step by step. The Rangoon substation. Everybody is as busy and tense as they are at Lopita. Congratulations! All tests have been highly successful. The long and untiring efforts of the 200-member staff of the Electricity Supply Board, 360 engineers and technicians from Japan, and 3,200 workers have now been fully rewarded. On April 1st, 1960, the river Baluchaung began providing the Union of Burma with powerful energy. It was a great moment in the history of the modernization of the country.